Sulphur dioxide. Sulphur forms two oxides, sulphur dioxide and sulphur trioxide. Sulphur dioxide occurs in volcanic gases, and small amounts of it are found in the atmosphere wherever coal, coke, or even oil is burnt. This pollution is harmful. Besides aggravating bronchial troubles, it also causes damage to plants and monuments. Sulphur dioxide can be prepared by the following methods. 1. Sulphur burns in oxygen to produce sulphur dioxide. 2. Some metallic sulfide, such as zinc sulfide, copper sulfide, when burnt in air or in oxygen, produces sulphur dioxide. Place some copper turnings in a 500 milliliter round-bottom flask fitted with a thistle funnel and a delivery tube. Pour some concentrated sulfuric acid carefully through the funnel until it covers the copper turnings. Next, heat the flask gently. Sulphur dioxide evolves in a continuous stream. Collect the gas in a jar by upward displacement of air. Do not smell the gas directly, since it is poisonous with a suffocating odor. Sulphur dioxide is a colorless gas. It is 2.5 times heavier than air. It is highly soluble in water. It is poisonous and causes inflammation of lungs. Sulphur dioxide is used to preserve dried apricots, dried figs, and other dried fruits. It is also an important compound in wine making and a useful reducing bleach for papers and delicate materials such as clothes. Let us perform the fountain experiment to demonstrate that sulphur dioxide is highly soluble in water. Fill 100 milliliters of round-bottom flask with sulphur dioxide. Fix a 2-hole rubber cork containing a jet tube and an ink filler filled with water. In a 250 milliliter beaker, add about 100 milliliters of blue litmus solution and dip the end of the jet tube into it. Press the rubber cover of the ink filler. Water now enters the round-bottom flask. The blue litmus solution rushes into flask as fountain and turns red. This is because when we press the rubber cover of the ink filler, water enters into the round-bottom flask. Sulphur dioxide present in the flask dissolves to form sulphurous acid, which creates vacuum in the flask. The blue litmus solution turns red since the flask contains sulphurous acid. 1. Reaction with metals. Sulphur dioxide is neither combustible nor a supporter of combustion. In this reaction, sulphur dioxide acts as the oxidizing agent and oxidizes magnesium to its oxide. 2. Addition reactions. Sulphur dioxide reacts with oxygen in presence of platinum catalyst at 400 degrees Celsius to 500 degrees Celsius to give rise to sulphur trioxide. 3. Acidic nature. sulfur dioxide combines with water to form sulfurous acid. This is why sulfur dioxide turns moist blue litmus to red and neutralizes alkalis to form salts. 4. Sulfur dioxide as reducing agent. Sulfur dioxide reacts with moisture and liberates nascent hydrogen, which acts as a powerful reducing agent. 5. Bleaching agent. The nascent hydrogen formed combines with vegetable and animal coloring matter and renders it colorless. This bleaching action is, however, temporary. The equation may explain this. Sulfur forms two oxides, sulfur dioxide and sulfur trioxide. Sulfur dioxide occurs in volcanic gases, and small amounts of it are found in the atmosphere wherever coal, coke, or even oil is burnt. Sulfur dioxide can be prepared by burning sulfur or metallic sulfide in oxygen. It is a colorless gas and is highly soluble in water. It is 2.5 times as heavy as air. Sulfur dioxide is poisonous and causes inflammation of lungs. Sulfur dioxide reacts with metals and undergoes addition reaction. It acts as a reducing agent and has a temporary bleaching action.